Boys, Kenneth, can we focus today? Okay, we're getting started. You'll have to come see me after. Okay? So for this, let's say I have a circle. Are we following? So I have a circle, and the area is 100 centimeters squared. Okay? Today we're going to be doing... So today we're going to be reviewing how to solve for a pentagon, a hexagon. Okay? Because I know that the pentagons and hexagons, heptagons, octagons are the most confusing part. Right? So that's why we're going to do these types of questions at the beginning just to refresh our minds until it's clear. Right? But also taking notes is a good habit. It helps you remember. Okay? If you don't have paper, you can come and get some up here. Okay? I'll gladly give you anything you need to take your notes.
What's the title?
So this is just equivalence review.
Equivalence.
So let's assume I have a circle. So I'm going to assume, boys, gentlemen, can I get started? Andrew. All right. So this circle. Instead of saying hey bro, let's say hey math. Okay? Because it's like. So here I have a regular hexagon, okay? So note that it's a hexagon. And I want to fill this hexagon up with 100 centimeters squared of area. So they're equivalent. My circle and my hexagon are going to be the same. All right? So here I already told you the area, so there's no solving really necessary. You don't need to derive the area from the radius. Like you're going to see in your assignment today, that's what you'll have to do. Okay? This is entirely possible, okay, for a hexagon, if I have no information here. Because if we remember, hi boys, if we remember, right, the area for a hexagon is simply the perimeter times the apothem divided by 2. Right? This is the area. But in this case here, do I have either of those values? No. Right? So that means that we need to use trigonometry. Okay? Boys, you walked in late. Mr. AirPods, you? Can you come up here? I'm trying to make you learn. I want you to sit up here.
Those are not squares.
All right. Can we continue? I know, but we're taking notes now, okay? So here I have a hexagon. And in my hexagon, right, if we know that it's a regular hexagon, we're going to do this with any shape that's more like 5 sides and up, okay? if I put a point, it'll tell you it's regular. If it's irregular, you can't solve. You just simply write can't solve, but they won't write you that because you can't solve. In the hexagon, you can break it up into the 6 triangles, right? Because triangles is the skill that you were supposed to be learning right throughout this entire time, so that you would have the skills to use triangles, right? So that if we break down bigger shapes into triangles, then we can solve the triangle and just multiply. So here, I have 6 of the exact same triangles. Can we see that?
Yes.
So 6 of the triangles, they're all the same. So I'm going to take out 1 here, okay? Because what can I do if I solve this triangle? What logic can I apply to the hexagon? Multiply it by 6, right? So the idea here is that I solve for this triangle here, and I'll just multiply it by 6. So that's it. So that's why I'm going to show you today if I have absolutely nothing. This is the most difficult question you'll encounter, which is why I'm trying to do it. So if you can do this, you're good for everything.
So like as an example, like all these numbers are 100 centimeters.
Exactly. And that it's a hexagon. Okay?
What did you divide it by 6 equals?
But we're trying to find the dimensions. Okay? So that's the purpose of this, right? Because they might be asking us to find the perimeter of the shape, but they might ask us to find the apothem. They might ask us a whole bunch of questions. We're trying to find the dimensions. That's the question. Okay?
Should I be writing this down?
Ideally, yeah. So that you can remember.
Can I go back downstairs?
No. You're so good. You're like focusing, and it's beautiful. So here.
He's talking to me, so can you move him?
No. He's already at the front. Where do you want me to move him? Like here? Okay. So what do I know about the area? What do I know about the area of this triangle? Okay, what do I know about the area of this triangle? How do I solve for the area of a triangle? Base times height divided by 2. Okay. In this case here, if I have 6 times base times height divided by 2.
Hey, over there. Hey, yo, Ben, Yo, I got something better right here. Yeah, Oliver, tell the shit up. Although last time I checked, you don't have to. Last time I checked, I don't know what you said, but shut up. Shut up. Your mom should
No. It's either we're all in the same boat or we're not. You know it's going to be impossible to watch this recording? Do you realize that even if you go home and watch the recording, that like you'll absolutely be able to like learn nothing because you'll have to wait 20 minutes in between? I'm not going to edit the video. Okay. Can I continue, please? I'm going to continue. If you don't want to follow and you want to stick on your phone or listen to your music, then be my guest. But I want you to be able to do this. This exact same question is going to pop up. Exact same. So 6 times base times height divided by 2. So this here, right, this is my triangle. I want 6 of these triangles. And 6 of these triangles here is going to equal 100 centimeters squared. This is my equivalent statement. This is saying that my circle, which is 100 centimeters squared, is going to be equal to my hexagon. So if you want to write a little reminder that hexagon is equal to circle, okay, then that might help you out. In this case here, we have base and height. Base and height are variables, right? Variables mean what? What's a variable mean? So something that varies, right? So it's something, a letter that we use to represent infinite values. So we're not sure until we solve. Can we solve this information? Can we solve this equation? Right? This is an equation. Can I solve with 2 variables?
No.
No. So when you guys were doing, for example, linear algebra, and you did 3x plus 4y is equal to 7, and then you had another line, right? You had like 4x plus 9y is equal to 14. Okay? You use substitution or elimination, right? So if you had an x and a y, you also needed to find another equation with both an x and a y. That was a skill that we were building to be able to solve 2 variables. You need 2 pieces of information. Here we only have 1 piece of information. If it doesn't make sense to you, that's fine. I'm going to show you how to do it. You remember the shortcut. You write the shortcut on your memory aid, and you can solve. Okay? So here, I'm going to have base. And that's it so far. Can I find the angle up here? Because this angle is really here, right? And remember with the pentagon, we've done it before, is the whole 360. So if I take a full circle, divided by 6, right? So this angle here is 60 degrees. If this one and this one are equivalent, then what are these angles? So they're also 60.
So you do. Yeah.
The top one? So if, for example, right, you have a pentagon, would you divide by 6? No, you divide by 5, right? That's an important distinction, is that depending on your shape, when you draw the circle is going to be divided into different amounts of pie slices, right? So if this was a pentagon, you can't do 360 divided by 6 for a pentagon because you only have 5 triangles. So you do 360 divided by 5. Okay? So what do we know if all of the angles are the same on the inside? What do we know about the side lengths? So all the sides are the same.
Wait, how did you get the 60 for each corner?
Okay.
The 60 was 360 divided by 6.
Yeah?
And then the other ones.
So the other ones, I did 180 minus 60 is equal to 120, right? Because this is all the angles in a triangle is 180.
Wait.
We know that within a triangle, if you add them up, it's 180, right? And I took away 60 here, okay? But I know that this one and this one are the exact same.
Because it's the same size.
Well, in this hexagon, right, they're the same.
Yeah.
So I knew that it was just 120 divided by 2, which is 60.
Being the flat.
The full. Well, 180 is also half circle, but that'll confuse you. But if you add up all the angles in a triangle, it's 180. So if you don't know that, then that's a good thing to add to your memory aid. Okay? That all angles in a triangle equal 180 degrees. Okay? So I took away the top angle to solve for these two. Yeah. Okay? So if I know that all the angles on the inside are the same, that means that all the sides are the same. This is an equilateral triangle. Okay?
What's the C mean? Like all C?
Where's the C? Oh, all angles.
Oh.
This is the symbol for an angle, if you draw it sharply. Okay?
All angles. And then
In a triangle are equal to 180.
I'm sorry.
I'm trying to write it on your memory aid, right? So you write it as small as you can.
Oh, okay. Well,
That's like my logic here. No, for every triangle, 180. Yeah. But they're not always going to be right all the same. You know, in a right angle triangle, you have one right angle, which is 90, and then the two other ones also have to add up to 180. Okay. So now, do I have any tools? Any tools to deal with this type of triangle? Because I don't. Okay? Unless you want to use cosine law, but I wouldn't go there. Boys. Okay? So here what I'm going to do is split it up into a friendlier shape. Okay? I'm going to split it up into this. And then I want you to label this triangle.
Hello.
Kelsey? Kelsey? Are you here? Yeah. They wanted to see you in the office. All right, thank you. Bye. Both of you. Yeah, but you were gone to the washroom. Okay. So in this triangle here, I can label this. So the bottom half is going to be what? What's this length? What's this length? So base was the whole thing. So half of base.
Wait, what did we just?
Okay. What? That. This is the simplified version. I realized after that I didn't simplify all the way. Height is just half of base. But that's where I'm showing it again, the process, just in case you need to remember. Okay? This is later. Okay. So here I have half of base. Here on this side, I still have the full length of base, and here I have height. This I know is a right angle triangle, and I also know the angles here, but that's unnecessary. Because what I want to use here, okay, what can we use for right angle triangles? What's our special Pythag? Okay, which is equal to c squared is equal to a squared plus b squared. So I'm just gonna label this. All right. So this is c, this is a, and this is b. What I'm trying to do here, right, is that up here our issue, the entire reason we're doing this, is that I had two variables, base and height. Okay? I cannot solve with two variables. So I need to express the height in terms of base. Okay?
Put the steps one, because it's like.
But I'll show you the shortcut after. And the shortcut is literally, you go from this, you add the shortcut, and you solve. Okay?
But wait, are these our notes? Like, this is our note taking?
Yeah.
Okay.
I can do that in the future. I don't mind. Okay? I'll take it gladly into consideration. So here. So for c squared, I really have base squared. A squared, I have height squared, plus half of base squared. It's okay. I'm just moving it.
So can I go back a way?
2? No, you're working so well.
No, but I was hard over there. Sir, I won't talk at all.
I don't settle for fine. I settle for good.
Wait, you said yeah?
I said no.
Why?
Okay, so here I have base squared is equal to height squared plus half of base squared. My goal is to isolate h. So to isolate h, I have to subtract the half base squared. So I have base squared minus half of base squared is equal to height squared. So here if I have the full base and I take away half of the base, how much do I have? Half of base squared is equal to height squared. How do I isolate for the h? Yeah. So square root both sides. So here I have height is equal to half of base. This is the shortcut that you write on your memory sheet. If you don't, you have to do all this math again. Okay? So now I'm going to do the step-by-step thing. Sounds good?
So wait, so you just have to like follow along on this one and now what you're writing?
Well, if you followed this and you understood, then that's good. If not, I'm just re-summarizing. So first step, equivalent statement.
Wait, are we doing the same shape if we do
It's still the same thing.
different when solving?
No, I'm just summarizing everything I wrote.
Like we took this shape, separated it into a triangle, and now it's half a triangle.
Yeah. But you'll see. So my equivalent statement was that area of a circle is equal to area of a hexagon, which we concluded was equal to 100 centimeters squared is equal to 6 times base times height divided by 2. Oops. Okay. That's number 1. Number 2, use shortcut. What? Sorry. I'm just redoing it in steps. So if that didn't make sense, hopefully this will. Use shortcut. Height is equal to half of base.
Maybe.
All right. So step 1, we start with our equivalent statement, which means that the area of our circle is equal to the area of the hexagon. So here we wrote out, for this question in particular, 100 centimeters squared is equal to 6 times base times height divided by 2. Okay? When the past comes back. Use the shortcut. So height is equal to half of base. We sub this in to the equation. So here instead of base times height, we do base times half of the base. Now we only have one variable. So we can solve. Base times half of base. So what's 1 times a half? Half. And then what's base times base? Base squared. Okay. Divided by 2. So I just did base times half base is half base squared. So we're solving for the base of the triangle. This is full base, right?
So what does that say? Sub in?
Sub in, yeah. Substitute. Everyone's good so far?
I'm not done yet.
Wait, when you're done that, can you like draw the like little pictures on the side or have
Sure. So here, I have the area of my triangle, if you remember, is just base times height divided by 2. So here I have this, I simplified. Base times half of base is half of base squared. Half of base squared divided by 2. So if I'm dividing by 2, I'm multiplying by the reciprocal, or is that too far? Do we not remember that? If we don't remember, then let's use our calculator.
like the half comes in, like half of it, like I get that it's half of the base, but like how come you're multiplying it by the other base?
So because this here, half base,
Yeah.
is height. So imagine this was base times height divided by 2.
You mean like the base and then like that's the half base? Is like the height of it?
So the height, we know, whatever the base is. Imagine the base was 4. We know that the height for an equilateral triangle is half the base. So it would be 2. So if you go back to this triangle up here, so this base is base, what we're talking about. This here is height. But we were able,
Half base.
so half base is the height.
Oh.
Because we're trying to, we can't write base and height. That's 2 different numbers. But I was able to show you how you can represent height by only using base. Right?
So like when you're solving for
Because
half
if I
base,
said in question 1 here, solve this,
yeah.
you wouldn't be able to solve it. Because you would have base and a height. So you can never get down to b equals like 4, right? Because you would always have an h in there. So I'm removing the h and replacing it by b's, which is here. H is equal to half of base.
But like say if you were representing half the base, you would say this is the height.
Yeah.
The triangle.
Yeah. So here I have, so here I did again, 100 centimeters squared, that's our circle, is equivalent to our hexagon, which is 6 times base times height divided by 2. Here I simplified up here, base times half of base is half of base squared. A half divided by 2 is a quarter. B squared is equal to 100. Okay?
But wait, base squared divided by 2 is in
Well, squared is up here, so we only divide the pre-numbers, the coefficients. This is a half divided by 2. Well, like technically it is, but if you take base squared divided by 2, you would get half of base squared, right? But here it's half of base squared divided by 2. It doesn't change the exponent. If it was like divided by 2b, then like yes, then you would divide the b's. Okay? But that's like arithmetic. Like it's kind of like okay? So 6 times a quarter is 6/4 b squared, which is equal to 100. 6/4 is really 3/2 b squared. 3/2 is 1.5 b squared. I'm just simplifying. I'm doing as much as I can without my calculator. Okay? And then after this looks simple, right? This is something we can solve, right? So first we do 1.5. So remember bed mass. We have to go backwards. So there's no addition subtraction here, but there is a multiplication between the number and the letter, right?
Sorry, I look away like 2 seconds. I'm reading a whole paper.
Well, because I'm writing like exaggerated here. Anyways, so the answer here is going to be b squared is 100 divided by 1.5.
Wait, where is this? Like, continue?
This is continuing this.
That's
I'm just solving it. But like I'm really taking exaggerated steps. You would probably go much faster in your like calculator. I just want to show like every step for you guys. Okay?
How come you didn't times the 6 to the 4?
What do you mean? So I did 6 times a quarter. Right? So if I have 6 like quarter slices of pizza, I really got 1.5 pizzas. This is just multiplying fractions.
No, I know. But like I don't get where.
So this is why, right? I want to do one of these every day until we get it. You know, it's going to be at that point just a repetition thing. But it's because I also want to give you time to work on your stuff. But when we spend 20 minutes just to get settled in, right, it's impossible.
Like you're gonna be showing us like say like an example problem.
Yeah.
Problem and then you're just solving.
Yeah. So 100 divided by 1.5 is I think 66.6. And then whoever said square root, right, you're correct. You do square root of this. So square root of 6.666 is really, so B is equal to 8.16 centimeters. Oops. This, yeah, sorry. Okay. So this here, if I redraw my picture, or if I go back, is everyone that's following up to this point? Yeah. If I come back to here, I saw that my base is 8.16. So my height, right, is half of my base, so it would be about 4. So I know for that this hexagon, the base is 8, the height here, like the apothem is 4. And then I... What's almost done?
Everyone is in the mission. I'm in this one, sir.
Okay.
Yeah? Thank you, sir.
Well, you can go because it's group work now.
Thank you, sir.
If you want to copy this down, I have it up here. If not, All right.
Down to electric
And I'm going to give you 2 minutes.
I'm a weeb, okay?
All right. So this here, for those of you that haven't been paying attention and just wasted the last hour of your life, this was leading up to the assignment. So this assignment is worth a lot more than just in-class work. Okay? So if the in-class work was worth 1%, this is worth like 5%. This here, you can complete in pairs. Each person must submit 1 paper. I'm giving you the end of this class and 20 minutes of the next class. If you do not finish it in 20 minutes, you won't get any more time. So next class, 20 minutes in. So ideally, you do it at home. And then we have it this one I am grading. I will look at the answer.
For sure,
All 3. Those 3 questions in the assignment. You can do it in pairs. Rate the team like your teammate. Here with your partner. This is also available on YouTube. So this is for next class. There's no extensions. Okay? If you want to look at it online, I made a shorter version of the URL because I know you use your phones probably. But everything's on YouTube too.
I didn't agree with you. Today I woke up and done like,
No, I ripped the paper.
where's my son? I wasn't in there.
Haven't seen his other side. The series that we auction is never showed up. I've never seen it back from that.
I have the formula. Someone stole my formula sheet.
Since the car was supposed to be
I had it taped to the wall, and someone actually had ripped it off.
so maybe my mom or my dad did.
The old guy.
Oh, it's small business. I'm going to say I got up. This is so quiet, I get up. I'm like, I didn't know, like, I wasn't